in this class. Now I am going to explain you a problem which was given in G Advanced 2023 paper 2, and it is a connective based question, and that connectivity is there between the continuity and differentiability, and this was given under multi correct choice questions. See, the function is given like this: f of x equal to step of 4x into x minus 1 by 4 whole square into x minus 1 by 2, where the symbol represents greatest integer function. You know, greatest integer of x value is either less than x or less than or equal to x, and the domain of this function is open interval of 0 to 1 and the range is capital R, and 4 options are generated. So we have to check that 4 options. It is given in multi correct choice questions means we may get either one option as correct or we may get more than one option as correct. Now see that 4 options. First one is the function f is discontinuous exactly in one point in this interval, and the second option is there is exactly one point in 0 to 1 at which this f of x is continuous but not differentiable. See the third option, that function f is not differentiable at more than 3 points in the interval 0 to 1, and the fourth option is the minimum value of f of x is minus 1 by 512. Okay, now let us check it. See, observe carefully. I am going to divide this 0 to 1 interval into 4 subsets. One is from 0 to 1. X is 0 to 1 is given na, so 0 to 1 by 2, and one more is 1 by 2 to see here 4x is given na, right, 0 less than x less than 1 by 4, and 1 by 4 to 1 by 2, and next 1 by 2 to 3 by 4. Now 3 by 4 to 1. I divided this interval into 4 subsets. Now in this interval, see here, so if x belongs to this interval, if you write that value here, how much this greatest integer of 4 into x value from here to here, if you take any real number from here to here, this result would be, tell me students, this 4x is going to be 0. Am I right? If you want to take any value and substitute here, you get this greatest integer value is 0. Yes or no students? Because in the simplification you will get 0 point something. So greatest integer of 0 point something is 0. Hence this function would be f of x equal to, so this is going to be 0. So now go to this interval. In this interval, if you write any value here, you are going to get this part is 1. If you want here 1 by 4 is included na, I kept less than or equal symbol. If you write here, it is going to be 1. 1 into something, this much only will be left. See here, x minus 1 by 4 whole square into x minus half. Now go to this interval. If you write here 1 by 2, so this is going to be 2. Not only this, if you take any value in this interval and substitute here, it is going to be given a value 2. So 2 into this much, 2 into x minus 1 by 4 whole square, x minus 1 by 2. And if you write any value over here, it is going to be 3. 3 into x minus 1 by 4 into x minus 1 by 2. Now in detail, we have written this function. Now check whose continuity and differentiability. In this type of problems, generally we use it to check continuity and differentiability at these boundary points 1 by 4, 1 by 2 and 3 by 4. Okay, and now let us check. See, if you want to check whose continuity at 1 by 4 and 1 by 2 and 3 by 4. Okay, I am going to check at 1 by 4 at x equal to 1 by 4. For left hand limit, you know, for left hand limit x value is smaller than 1 by 4. Limit x approaches to 1 by 4 minus, means which function you have to prefer? This. So here it is going to be 0. And right hand limit at this point, limit x approaches to 1 by 4 plus, means you have to consider this function x minus 1 by 4 whole square and to x minus 1 by 2. Now if you write this 1 by 4 in the place of x, it is going to be 0. 0 into something, 0. Now left hand limit is 0, right hand limit is 0. Hence at x equal 1 by 4, this function is continuous. Okay students? Right. Now if you want to check whose differentiation, you can. At x equal 1 by 4, it is continuous. Then evaluate whose left hand derivative and right hand derivative. If you do left hand derivative at x equal 1 by 4, again you have to take this function whose derivative is 0 only. And for right hand derivative at x equal 1 by 4, you have to take this function and do whose derivative and substitute in the place of x 1 by 4. So what do you get? Students, so take this function. So this function. So f of x equal to x minus 1 by 4 whole square into, see, x minus 1 by 2. Now do whose derivative? F dash of x. So here UV rule, x minus 1 by 4 whole square. If you do the derivative of this, it is going to be minus 1 by 2. UV rule I am following here. So keep it aside. This is u, this is v. U I kept aside, I did the derivative of this, I got minus 1 by 2. I am going to keep this is outside and do the derivative of this. It is going to be x minus 1 by 4. Now put x equal to 1 by 4. If you substitute x equal to 1 by 4, it is going to be 0. 0 into something 0. If you write x equal to 1 by 4, it is going to be 0. 0 into something 0. Finally, f dash of 1 by 4 you got as 0. So this was continuous as well as differentiable at x equal to 1 by 4. Got the clarity? Now, see. Okay students, so f dash of 1 by 4 you got as 0. Keep it aside. Now go to next boundary point at x equal to 1 by 2. At x equal to 1 by 2, now let us check left hand limit. If you find left hand limit, x approaches to 1 by 2 minus. So x value is smaller than 1 by 2. Smaller than 1 by 2 means which function you have to prefer, either this or this. It has to be taken. So write x minus 1 by 4 whole square into x minus 1 by 2. Now in the place of x, write this 1 by 2. 1 by 2, 0. 0 into something 0. It is going to be 0. Now find right hand limit at x equal to 1 by 2. Limit x approaches to 1 by 2 plus. So x value is more than 1 by 2. 1 by 2 means this function you have to prefer. So 2 into x minus 1 by 4 whole square into x minus 1 by 2. Now directly put in the place of x 1 by 2. 1 by 2 minus 1 by 2. 0 into something 0. Now left hand limit, right hand limit, both attains a real number 0. Hence this is continuous at x equal to 1 by 2. Right. Next. Yes. Now at x equal 1 by 2, do you want to check whose differentiation? You can. I am going to check it. X equal to 1 by 2. Okay, students. See, for LHD. For LHD, which function you have to take? This function. Now do whose derivative. So follow the UV rule. So keep it aside. X minus 1 by 4 whole square. And do the derivative of this. So what do you get, Amma? So already here we did same result you will get. F dash of 1 by 4 you got 0 na? So same like previous one, if you do it, see here derivative of this becomes minus 1 by 2, and again keep it aside and do the derivative of this. So you get 2 into x minus 1 by 4. Now in which put x equal to 1 by 2. If you put x equal to 1 by 2, what do you get? Students, at x equal to 1 by 2. So here, this is the here at x equal to 1 by 2, I am finding LHD. LHD means smaller than 1 by 2. So I preferred this function. I followed here UV rule. This I kept aside and I did the derivative of this. I got minus 1 by 2 plus x minus 1 by 2 I kept aside. I did the derivative of this. Now put x equal to 1 by 2. F dash of 1 by 2. Okay, students. See. Students, x equal to 1 by 2, if I write here, 1 by 2 minus 1 by 2. How much? 1 by 2 minus 1 by 4. Going to be 1 by 2 minus 1 by 4. LCM is 4 and here 2 minus 1. Going to be 1 by 4 only. So 1 by 4 whole square. 1 by 4 whole square. 1 by 16 into minus 1 by 2 you will get. So here 1 by 2, if you write 1 by 2 minus 1 by 2, 0. So this is going to be minus 1 by 32. At x equal to 1 by 2, we checked whose continuity. So this was continuous. I did the derivative. Left hand derivative I got minus 1 by 32. Now find the right hand derivative. So f dash of 1 by 2, you can write minus. So minus 1 by 32. Minus 1 by 32. Now find right hand derivative. F dash of 1 by 2 plus means more than 1. More than 1 by 2. More than 1 by 2 means this function you have to prefer. So same given, but before that 2 is there. So this one you have to follow the UV rule. Same result you will get. But before that what is there? 2 is there. So you have to multiply 2 with that. Minus 1 by 32 which becomes minus 1 by 16. Both are not equal. Here what you people are observing? F dash of 1 by 2 minus is not equal to f dash of 1 by 2 plus. Hence this function is not differentiable at x equal to 1 by 2. Remember this. We checked whose continuity at x equal to 1 by 2. So this was continuous but not differentiable. Okay, students? Right. So, yes. At x equal to 1 by 4, this is continuous as well as differentiable. And at x equal to 1 by 2, this was continuous but not differentiable. So f dash of 1 by 2. Okay. So write like this. At x equal to 1 by 2, f of x is not differentiable. At x equal to 1 by 2, f of x is not differentiable. Yes. Now next go to other boundary point at 3 by 4. Do see f dash of find at x equal to 3 by 4. Let us check left hand limit. What is left hand limit? See, this function you have to prefer and in which wherever x is there, there you have to put 3 by 4. In which put there 3 by 4. If you write here 3 by 4, okay students, what I am checking? Continuity of this function at x equal to 3 by 4. For left hand limit, we have to prefer this function. Wherever x is there, there you have to write 3 by 4. 3 by 4, if you write here, 3 by 4 minus 1 by 4 whole square, 3 by 4 minus 1 by 2. Now simplify this. So this is going to be, okay, 2 by 4. 2 by 4 means 1 by 2. 1 by 2 whole square. 1 by 4. Into what about this? Tell me students. 3 by 4 minus 1 by 2, which becomes 1 by 4. Now you got this result as 2 ones are 2 2s are 1 by 8. At x equal to 3 by 4, left hand limit attains 1 by 8. Now check right hand limit. Right hand limit. Tell me students, at right hand limit, how much do you get? Right hand limit. Prefer this function. Limit x approaches to 3 by 4 plus. Take this function. 3 into x minus 1 by 4 and x minus 1 by 2. Now substitute in the place of x 3 by 4. So what do you get? 3 into, if you write here, it is going to be 3 by 4 minus 1 by 4, which becomes 2 by 4. 2 by 4 means 1 by 2. Okay, now if you write here 3 by 4 minus 1 by 2, so which becomes 1 by 4. Now you got 3 by 8. 3 by 8. In the previous case, how much have we got? So here 2 into 3 by 4, if you write here 3 by 4 minus 1 by 2. See, 3 by 4. Yes, 2 by 4. 1 by 4 is the result. And 3 by 4 minus 1 by 2. 1 by 4. So here you got 1 by 8 as answer. So here 3 by 8. Left hand limit 1 by 8. Right hand limit 3 by 8. Both are not equal. Hence this function is not continuous at 3 by 8. This function is not continuous at 3 by 4. What result you have found here? At x equal to 3 by 4, f of x is not continuous. Not continuous. Okay? So like this you have to check and go to the options. Which option is correct? What is first option? F of the function f of x is discontinuous exactly at one point in 0 to 1. Yes, first option is correct. Why it is correct? Because at 3 by 4 function is not continuous. At remaining all points, so this function is continuous. And what is second option? See, there is a exactly one point in 0 to 1 at which the function f is continuous but not differentiable. Yes, at x equal to 1 by 2. We checked whose continuity. This was continuous but not differentiable. Second one is also correct. What is third one? See students, what is third one? The function f of x is not differentiable at more than 3 points. Is this correct? No, wrong. It is not differentiable at only 1 point, that is x equal to 1 by 2. Okay students? Right. See, third one is wrong. Now last one is the minimum value of this function f of x is minus 1 by 512 is given. You know, minimum value. Actually, when do we get minimum value? See, whenever the derivative, first derivative of the function changes its signs from plus to minus. Okay? So now check it. Plus to minus. So here, okay, you better to check in this interval, Amma. So here at x equal to 1 by 4 you got as 0 na, here it is 0. And at x equal to 1 by 2 find whose derivative, minimum value they mentioned. So do whose derivative, you know how to find the minimum value of the function. So take this function and you may get that minimum value in any one of these 3 intervals. So you would have to check that minimum value. How to find minimum value, you know, you have to take this function and you have to go for whose first derivative. If I do whose first derivative, how much have we got at x equal to 1 by 2? Do first derivative. See, I took this function. So now differentiate it. So keep it aside and do whose derivative. I am following here for UV rule. This is going to be minus 1 by 2. And keep it aside and do the first derivative of this. You get 2 into x minus 1 by 4. I did the first derivative. Now we equate this first derivative equal to 0. Then what do we get? How to check a minimum value? You know, I did the first derivative and you do equate this one equal to 0 so that we will get critical value. And do the second derivative also. If the second derivative is positive, then that function will attain minimum value. So, are you getting me, students? First you have to take this interval and you have to do the first derivative and equate that first derivative equal to 0. You get the critical values and do the second derivative. Substitute that critical value in the second derivative. If the second derivative attains positive value, so at whichever point that second derivative attains positive value, at that point that function will be minimum. You know, like that you need to check this interval, this interval, this interval. But here the minimum value of this function f of x is minus 1 by 512 given. So that minimum value of this function attains in this interval, but that minimum value is different than minus 1 by 512 you will get. Hence this is also not correct. You check by yourself this. How do you check? I did the first derivative. So here take x minus 1 by 2 common and factorize it and equate them to 0. You get 2 critical values. And do the second derivative. And substitute that critical values in the second derivative. If the second derivative is positive, then that function will attain minimum at that critical value. Now if you want that minimum value, that critical value must be substituted in this function. So you will get other than this minus 1 by 512. Okay. Check this minimum value of that function. Whether are we going to get minus 1 by 512 or not. You will get other value than this minus 1 by 512. Hence I am saying that this fourth option is also not correct. Thank you.